first question was, I guess, this. Okay. This was a very easy question. See, the only difference here is to what we want to print. See, the rows numbers are same. Their rows are varying from 1 to 5. Okay. And the columns are again, see, in the third row, there are 3 columns. In the fourth row, there are 4 columns. So the column numbers are varying from 1 to the number of rows. But what we have to print is, we are basically printing the row number. Do you see? 3 is getting printed in the third row, 4 is getting printed in the fourth row. So basically we are printing R value here. Okay. So I'll quickly write the program for you if you guys have noticed it. Okay. R is equal to 1, R less than equal to 5, R plus plus, sorry. Okay. For C is start from 0, then there will be one extra column in every row, which we don't want. And if you start from 0, if you want to start from 0, then make it less than R. They don't make it less than equal to. Okay, because it is basically deciding the column numbers, number of columns, and we are not printing C, so it doesn't matter, but the number should be same. So either make it 0 and less than R, or make it 1 and less than equal to R. Okay, the only difference is in the print statement. We are going to print R here. Okay, and then after this loop ends, we are going to do a line change. Okay, and then we end this bracket. I'll not put any bracket here because there's only one line, so this belongs to this for statement. I hope this question is clear to everyone. Okay, we move to the next question. Okay, the next pattern was 1, 2. I think it was this. Okay. See that as earlier the rows are varying from 1 to 5. Okay. But in the first row there are 5 columns. In the second row there are 4 columns. In the third row there are 3 columns. In the fourth row there are 2 columns. And the fifth row there is only 1 column. So basically R is varying from 1 to 5. Okay. But column, where is column varying from? Column is varying from there can be many ways actually. Okay. Someone can say like it is varying from 5 till 5 till what? 5 minus 1 is 4. Okay, so it is, yeah, it is varying from 5 till the row number. Okay, for example, this is the row number 1. So backward counting 5, 4, 3, 2, 1. This is the best explanation. If the row number is 3, so it will vary from 5, 4, 3. So there will be 3 columns. Or you can also think of it like this. In the first row, there are 5 columns. So what we do here is, if you understood this, it's really easy. After that, we use a separate counter, int n equals to 1. Okay, because this counter will update it every time it is printed. Now for R equals to 1, R is less than equal to 5, R plus plus. For C equals to 5, we start from 5. Okay, C is greater than equal to R, C minus minus. Okay, now what we do, we print n first. Printf percentage dn. So basically, what is the first value of n? The first value of n is 1. So 1 is printed. Now as soon as 1 is printed, we do n plus plus. Basically we update n. It becomes 2. So the next time when this loop, whenever the n will be printed, so its value will be 2. And whenever it is printed, it gets updated, because this all is in one code block. So as soon as it is printed, it is updated, and after it is updated, it will be printed. Okay, then as usual we just change the line and we close the block. I hope this is clear to everyone. If anyone has any doubt, you can ask. Now what was the third pattern? The third pattern was 1, 2, 4, 3, 6, 9, 4, 8, 12, 16, 5, 10, 15, 20, 25. Okay. See guys, the row number as you can see is varying from 1 to 5. Okay. And the number of columns is also varying from 1 to the number of rows. See how we decided, for example, this is the third row. So how many columns are there? 1, 2, 3. In the fourth row, there are 1, 2, 3, 4 columns. So it's varying from 1 to R. Now, what are we printing? In the third row, this is first column, this is second column, this is third column. So this is 3 into 1, this is 3 into 2, and this is 3 into 3. So basically, we are printing row number into column number. As once you've decided these three things, then you can easily write the program. What we have to print and how the numbers are varying. So for R is equal to 1, R is less than equal to 5, R plus plus. For C is equal to 1, C is less than equal to R, C plus plus, printf percentage D, R into C, printf line change, and close brackets. Okay, this is a program. Take some time to absorb it, and if anyone has any doubt, you can ask. Okay, guys, I'm assuming that nobody has any doubts. So these were some of the simple pattern programs. Okay, and they are enough for now. Of course, there are many different pattern programs also, but we don't require them right now. Okay, now we did for loop yesterday, but there's another conditional statement called while loop. Okay, actually it has a condition as well as it acts like a loop. Okay, so what is the English? See, always remember what is the English meaning of while. For example, do this while you say, na, study while you are in college. So while you are in college, it is a condition. Do something. What is that? Do something. Study. Okay. So while you are in college, study. This is the syntax for while loop. Okay. So basically, this is called the test condition. Okay. This condition is tested every time you have to enter the code block. Okay, if this condition is true, if you are in college, then do what? These statements will be executed. Basically, these are set of instructions: study plus play plus code plus join clubs plus be fit. Otherwise you'll think that I'm only talking about study because I have not done it. Okay, now see, there's some similarity between a while loop and a for loop. What do we do in a for loop? Here we initialize, then there is a test condition, then there is updation. Okay, now in while loop, here is the test condition. This is the test condition. This doesn't mean that in a while loop there is no need for initialization and updation. Yes, there is a need for initialization and updation. Where do we do that initialization and updation? Initialization is done before the while loop starts, means it is done before it, initialization, and updation is done inside the code block. Okay, so basically these two parts are also present. This comes before the while loop and this comes within the while loop. Okay, it will become clearer when we see an example, and it is basically used while program when we want some, there's some condition till and until that condition is true, you have to keep doing it. Okay, for example, if you go to a Paytm, sorry, Paytm channel, ATM machine. So in the end, if you have done all your transactions, so they ask you that, okay, do you want to exit or you want to do another transaction? Now that is a conditional statement. It depends. It totally depends upon you. If you say that, okay, if you press Y and if you say that no, I want to do another transaction, then the program will get executed again. Okay, so it cannot be done with a for loop because the programmer doesn't know how many times you want to take out money, how much money you have. You are a millionaire or billionaire, or you have only 10 rupees. So that is why a while loop comes handy there. Let us understand this with a program. I'll show you one, and then I can give you some questions. Write a program to a simple question. Write a program to enter a number and print the sum of its digits. Sorry. For example, 523 is entered, then your answer should be 10. Okay, this program should do this. If you guys want to take an attempt, you can take it in 10-15 seconds. I mean, it's not. Yes. See, first of all, we have to take a number from the user. Printf number, enter a number, basically anything. Then a scanf, percentage d, and n has already been declared. Just assume that. Okay. Now, see, we have to find the now sum. So basically, what we do is there are some ways. See, we have to extract the digits. For example, if it is 523, so we have to first find 3, then we have to get 2, then you have to get 5. So how do we do this? There's a very simple way in programming. If you do 523 mod 10, what do we get? If you find the remainder of any number with 10, you always get the last digit. Basically, you get 3, right? So this gave us the last digit. But the problem is that again, if you do 523 mod 10, then you will get the last digit only. But now we want the second last digit. So we will change the number. How will we change the number? We will use the casting error to our benefit. See, I'll make 523 by 10. So what is 523 by 10? It is technically it is 520.52.3, but since I have not used 10.0, it will give 52. This is an important use of casting error here. Okay. Now, if you do 52 mod 10, now what will you get? You'll get the last digit of 52, which is 2. So see, we extracted 3, we extracted 2, and similarly we can extract 5 as well. Okay. Now we will implement this thing in program. Just take 5 seconds to understand this, and then we will implement this same thing in our program. The only difference is that we don't have a 523, we have a n, which is entered by the user. 3 int 2. What is this int 2 meant to? What do you want to say? I okay, you're giving the output. Fine, fine. Sorry. Yes. Okay. So let us try to implement this in our program. See, n has been entered by the user. Now what we do, we use a variable x to always store the last digit of n. Okay. X is equal to n mod 10. Assume that I have already declared x somewhere above. Okay, though I have not. I'm sure you guys will take care of that. Okay, x is equal to n mod 10. So x gets what? The last digit. Now we want to store the sum of the digits, right? The question asks that. So we have to create another variable here. Just sum equals to 0. Okay. Now sum is initially equals to 0, but now sum is equal to sum plus x. Okay. See, why it is necessary to specify initialize sum beforehand is because when the compiler comes to this statement, for executing this statement successfully, it needs some initial value of sum, some initial value of sum. So if you haven't given any value, it can give you a compilation error. Okay. Similarly, we do it in factorial program. We initialize the f variable with 1. Okay. Sum is equal to sum plus x. Now every time the digit is extracted, okay. Oh, sorry. We didn't put the while loop itself. This is a problem of too much zoomed in the screen. Sorry, guys. See, there has to be a while loop here. Once we have taken input in while n not equals to 0. Okay. Now we'll understand. You will understand how this is working. Now within the while loop, the first thing which we do is we extract the last digit of n by n mod 10. Okay. Then we store it in sum. Sum is equal to sum plus x. Now before we go back above, we have to trim n, because if we close the bracket here, n is not changed. So every time it will give the last, if it is 523, so every time x will get 3, and you will keep on adding the sum of 3 only, which we don't want. So we can't close the bracket without updating n. See, this is the update statement which we use, which we put in the third place in the for loop, that is done within the loop. Okay, n is equal to n by 10. Now we close the brackets. Okay, so now let us understand this with an example of n. For example, n is equal to 523. First, this condition is checked. While n not equal to 0, 523 is not equal to 0, right? So it is true, then this block will get executed. X equals to n mod 10. So what is the value of x? 3. Sum is equal to sum plus x. So 0 plus 3, which is 3. N is equal to n by 10. So n becomes 523 divided by 10, which is 52. Remember, casting error. Now this 52 goes back here. Now is 52 not equal to 0? True. So again this block will get executed. So now what is the value of x? X equals to 52 mod 10. So that will give 2. Now what is the value of sum? Sum is equal to sum plus x. So 3 plus 2. So 5. And then n is equal to n by 10. So 52 by 10 will give you 5. Again this value went up, goes up. Is 5 not equal to 0? While 5 not equal to 0? Yes, true. So now x value is 5 mod 10, which is 5. Some value is 5 plus 5, which is 10. And n's value is n by 10. So it is 0. 5 divided by 10, 0.5, which is trimmed to integer. So it gives you 0. Now when this 0 value of n goes here, n not equal to 0, this condition becomes false. So this loop is exited. You come out of the loop, and you can see in the sum variable you have the sum stored here. So you can easily print the value of. I hope it is clear to everyone. Okay, so you guys can take an attempt at a program. Input a number, write a program to input a number, and print me the square of the reverse of that number. For example, if I give you the input as 31, then your answer should be 13 square, which is 169. Okay, so you have to take an input from the user and you have to print the square of its reverse. Just give it a try, guys. See, the challenge here is you are getting the digits, but with those digits you have to manufacture or fabricate the reverse number. You have to think how. For this, just remember the way we used to expand numbers when we were in maybe first grade or second grade. The similar way you have to use the digits to make that number again. Okay, I hope you guys would have taken an attempt, or at least a mental attempt, which is necessary. See, what we'll do is, for example, you get 523. So we already know how we can get the last digits, right? So you know how to extract 3, you know how to extract then 2, then 5. Okay, but how to make the number with 3, 2, and 5? So if you have to make 325, what was the thing that we learned in KG? 3 into 100 plus 2 into 10 plus 5. If you do this with these digits, then you will get 325. But the second challenge of this program is that it is a user defined number. Okay, so you don't know it is a 3-digit number or a 7-digit number, so you can't directly do 3 into 100 plus 2 into 10 plus 5. I hope you're understanding what the challenge is. So what we do is we do something else. Okay, let me just show you. Yeah, of course. I hope you have understood till here. We take an input from the user. I'm not writing till here. Okay. Then we do this while n not equals to 0, of course. See, x equals to n mod 10. So you get the last digit. Okay. So for example, you have 523, so you get 3 here. Then what we do is we have a number, we have already a sum. Instead of sum, we have a variable result. Okay, if I do that much of abbreviation, then some people might get confused. Okay. I have a variable called res equals to 0, which I've created. Okay. Now I'm going to use it, and just pay attention how we are going to use it. See, res is equal to res into 10 plus x. Okay. Now rest everything will be same. N will be trimmed again, and this bracket will be closed. Now just guys, just try to understand this part. See, you have a 523, so first 3 comes here. Okay. Now res initial value is 0. So 0 into 10 plus 3, so it becomes 3, right? Now n is equal to n by 10, so the new value of n is 52. Now again, the next value of x is, now next the value of res is 3 into 10 plus 2, which is 32. Okay. And when now the n gets trimmed, it becomes 5. Then if you get 5 here, then next 32 into 10 plus 5, so it becomes 325. You see how this statement is helping us to get the reverse of the number. If you understand this, then the program is done. We just have to do the square of res and we have to print. I think that's something very easy for every one of you. Is it clear for everyone? Okay, I'm hoping that it is clear for everyone. Next line has nothing. We just printed printf percentage d res into res. Okay, the square was to be printed. I just asked to print square because then some of you might have converted this to character, and you try to take out the characters one by one. So that is not what we wanted. Okay. If you guys are ready, then we can do another question. So write a program to enter a number and count the number of times the digit 5 appears in it. The user can give any size of number, and you have to count how many times the digit 5 comes in that number, and you have to tell that. Come on, guys. It's a very easy question. You can just if you have taken an attempt, you don't need to write the entire program. If you know that, okay, this is the crux of the program, which is the essential part, so you can write it in the chat box and we can discuss on it. This way it will help me to eliminate the errors in your thinking process. See, this question is quite clear. I'll quickly do this. While n not equals to 0, x equals to n mod 10. Now see, I create a counter int c equals to 0. This is a counter where we are going to count the number of times the digit 5 is coming. See, when we are doing x equals to n mod 10, basically when the loop gets executed, all the digits of n will one by one come in x. Okay, so we just check if x equals to 5, c plus plus. If x equals to 5, update the value of c. That is it. Now the as many times the digits will be 5, c will get updated if they are if you have entered 5250. So whenever the x value is this 5 and this 5, so c will get updated, c will be 2, and then you can print the 2. Okay, you can print with a beautiful statement that the number of times the digit 5 is coming in your program is 2. That is not the matter. The important thing is to understand this part. Okay. I hope it is very clear. If anyone has a doubt, just ask now. You can understood this. I would like to like you to take an attempt at this question. Uh, Write a program to enter a number and print whether the product of the first two digits. You can do it, just note down the question. You can attempt it at home. Okay, it might require you to think a little bit. Where the product of the first two digits is equal to the product of last two digits. For example, if I enter a question number like 525173. So what is the product of the first two digits? 5 into 2 is 10. And the last two digits 7 into 3 is 21. So they are not equal. So it should print that the product is not equal. And if the product is equal, then it should print that okay, the first two digits and the last two digits, the product of products are equal. I hope you understand the question. Just make a note, take an attempt, give it some time. Okay. I'll just tell you it. The tools that you require have already been taught to you in the previous three questions. Okay. You just have to apply your thinking ability and try to think how we can crack this, how you can crack this technically. And I'll discuss this question in the next class. Either note down the question or take a screenshot. Okay, guys, you'll understand a small part now. Do while. It works similar to while statement. It's the only difference is see while is an entry control loop, while do while is an exit control loop. Means what? See, in while the condition is tested at the time of entry itself. So, for example, in the first time only, if the condition is false, then the loop will not be executed even once. But in do while, it is exit control loop. When the loop is exited, then the condition is checked. This means that even if the condition is false, the loop will get executed at least once. So these are used in programs where we want to execute the loop at least once, especially in some menu driven programs. For example, your ATM machine, they want you to start the program gets started even if you don't have any money in your bank. And in the end, if you put that okay, I want 10 lakh rupees, and your account has only 10 rupees, then they will exit you, of course, instead of giving you money. But the program gets executed once. So you can just, I'm giving an analogy to explain that menu driven programs are mostly, if they can be done with do while loop. The syntax is quite simple actually. Okay. uh, a do statement is there, then the statements which are to be executed, and at the end there is the while statement. This is the condition, and there's a semicolon here. Okay, this is important. So what happens, this, there's no end. You can see that the condition is checked at the exit point. So the loop is getting executed once this enter it all the control always enters this loop. These statements are executed once. While exiting the condition is checked. If it is false, then the loop is exited, and the execution control goes to the next line. If it is true, then again these statements will be executed. Okay, this is all you need to know about do while loop. Okay, I hope it is clear. If anyone wants some time to absorb it, you can get an idea. Okay, guys. Now we'll learn about jump statements. Okay. Now, what are these jump statements used to do? They used to jump the control. Okay. So they basically, see, there is a flow of control in the program from this line to this line to this line. Now, if you want to have a jump in the control from this line, you directly want to go to this line, or from this line, you want to go to this line, or somehow you don't want these lines to get executed. So jump statements are used for that purpose. The jump statement that we'll be reading out are break, continue, mm, label, basically go to statement, and return statement. Okay, we'll read about them one by one. First, about break. See, you've already seen the use of break in switch statement. What break basically does it completely terminates the current loop. Okay. For example, for I is equal to 1, I is less than equal to 5, I plus plus, if printf, sorry, yeah, if I is equal to 3, break, printf percentage d I. Can you try to tell me the output of this program? See, the output of this program will be 1 and 2. That's it. Because when I equals to 1, this statement is not true, so the break is not executed. Okay. So 1 is printed by this statement. Then I equals to 2, still this is not true, so 2 is printed. But when I equals to 3, as soon as break is encountered, this entire loop, the control exits out of this loop, out of the for loop, and it comes on this line. So I equals to 3, 4, and 5 are never printed, so only 1 and 2 are printed. Okay. I hope you have understood the the concept of break. Now the next concept, yeah, somebody is asking. Continue. See, the name only suggests. इसको बोलता है ना, चलो आगे बढ़ आगे बढ़. So continue means that it takes the control into the next round of the loop. It doesn't terminate the loop, but that loop is superseded. For example, it will be clear, with an example. Instead of break here, sorry, instead of break here, if I write continue, then what will be the output of this program? See, when I is equal to 1, I is equal to 1, so this statement will print 1, so 1 will print it, 1 will be printed. I equals to 2, then 2 will be printed. Now when I equals to 3, as soon as this condition is true, so continue statement, what it does is, it takes the control into the next round. So these statements which are after that, they won't get executed. So I is equal to 3 is not printed, but the loop is not terminated. The next iteration is I equals to 4. So the loop goes into I equals to 4. Now I equals to 4 will be printed and I equals to 5 will be printed. So 1, 2, 4, 5 will be the output if you use continue, and 1, 2 will be the output if you use break. I hope this is clear to everyone. Now the next is break and continue are quite easy. That is why we use break in switch case, because if you don't use if you, as soon as break is encountered, see there is a case 1. As soon as the case 1 is true, we come here, we execute these lines, then break is encountered and the control comes out of the switch case. So that prevents the control to execute from fall through. So these statements are not executed. But if you don't put break, then after these statements, these all statements will get executed. Okay, which we don't want. Now coming to labels. See, labels have the same meaning which we have in real life. We put a label on something, no? Okay. For example, then society will put a label on you after 3 years that you are an engineer, while technically you won't. So label is like, something that has been put on some part, and that label for our name, for example, our names, they are a label. They are used to refer to us. So similarly, you can put labels to code blocks. Blocks of code can be given a label, and they can be used to refer to those code blocks whenever you want to execute those code blocks. For example, and labels are basically identifiers. Basically they are variables, so you can put anything. For example, Rohan. So Rohan can be a label for these 3 lines of code. Okay. and you and any times if you think that okay, if x equals to 3, go to Rohan. So if x equals to 3, if this condition becomes true, then the control goes back to this line, okay, and these blocks will get executed again. So this is a jump statement. The control jumps from here to here. You can even write go to first and label later. For example, go to some label, for example, Diya, okay, and the label can be somewhere down. Diya can be a label for these blocks of code. So it can be done in any way. For example, we can understand this with an example. Mm, okay, I'll write a program, and you guys can tell me the output of the program. Int n equals to 1. Example, I'll use your name as a label, just to show that sometimes what people get confused, that a label should always be referred to by the word label, which is not true. It's an identifier. You can use any word, arm, hindi. Okay, so printf percentage d n plus plus, if n is less than equal to 10, go to Rohan. Now tell me what will be the output of this program. I mean, what if in the end I printf n. I'm doing printf n. Tell me the output of this program. But this is not required. Okay. So yes, the numbers from 1 to 11 will be printed, because when n is equal to 10, again it goes to Rohan and it prints 11. Okay, yes, sorry. Due to the printf statement, yeah, if the printf statement was not there, if we give it like this, then we print from 1 to 10. If you give one more printf statement at the bottom, then you print from 1 to 11. I hope it is clear to everyone. I added one more printf statement by mistake. I hope it is clear to everyone. Yeah. So I hope labels is clear with this part. I mean, it's not such a big deal. Then we come to the return statement. I think we should learn it after. You will understand it much better when we read about functions, which is the next topic. But I'll just tell you that return statement terminates a function. Just keep it in mind. We'll just start functions and you'll understand it perfectly. Okay, and it also is used to return a value. Now, what is this value? If this value depends upon the function of that method. Okay, for example, if you use sqrt function, okay, then it returns the square root of your the number that you're passing it to it. Okay, so it terminates a function. Anyways, you'll understand it clearly. So it is also a jump statement. Now let's understand function. See this topic. Before we start this topic, if anyone has any doubt, please ask, because it's a very interesting topic, and this topic is something which is really eye-opening, because you get, once you understand functions, you get a bird's eye view of what programming is supposed to do, and a general idea of how things work. Everything, almost everything that you have used till now, whether it was printf, whether it was scanf, whether it was if, whether it was else if, whether it was return, whether it was while, even the main function you must have seen now, we used to write like void main. All these were functions. Okay, all these were functions. So you can see that whatever the main component that we use in our programming till now, they all were functions. Now in this part, we'll not only learn about the functions which have been given to us, but we'll also learn how to create our own functions. Okay. Now see, all these are inbuilt functions. Okay, functions are of two types: inbuilt, they're also called library functions. Okay, and user defined means the function that you can create on your own for your own purpose. Okay, if you have some special purpose, you are such a mathematician that you specifically want to do the square root of your factorial after multiplying with 527, you can create a function for that, and it will do exactly that whenever you call it. Implementing a function is called calling the function. So these inbuilt functions are basically that someone coded them, packed them in header files, packages, and provided you with them so that you don't need to code them every time. Like in taking input, producing output, using if else, simple things, while loop. Okay. And every program will have at least one function which is called the main function. The execution of the program starts from main function no matter where it is written. Okay. And these inbuilt functions are present in header files which have an extension .h. For example, if you remember, we write like this: include stdio.h. Okay, so this is a header file, std standard input output. So it contains the functions for input and output. So after you import it, then you can use those functions, those library functions. Okay. Now we'll learn how we can create our own functions. See why functions help us. There are some special uses. First of all, they make writing programs simple and fast. For example, we started with printf. Okay, now assume that before using printf, you had to learn a program to write to print a simple statement. Then programming wouldn't be that fun. So they make writing, many parts very simple and very fast. Also, debugging your programs becomes easier because, if for example, if there's error in a function, so if you just correct that function, that error will be removed from all the places where you are producing the output. But if you are doing it every time, so you have to correct it at every instance of that function. Also, it avoids you to from duplicating the code again and again. You can make a function and you can do it. Achha, remember that whenever we implement a function, it's called calling a function. It's a slang term. I might use it, so you should know what I mean. Okay, now let us see the syntax for a function. See, first is a return data type. See, depending upon the job of that function, the function can be required to return something to the person who is calling it. Okay, for example, a very simple example is, for example, you have a messenger. So you might just need him to deliver a message to your friend. Okay, so then he is not supposed to bring something in return. So then in that case, the return tag will be void. You just want him to go and deliver a message. That's it. But if you want him to bring a return message, for example, you are the king of Egypt and you want to get a message about a trade from Rana Pratap, king of Mewar. So your return data type should be something depending upon what you want. For example, if you want to value for silk, maybe. So you want an integer data type as a return. So your function, your messenger needs to know that okay, I am supposed to bring back an integer value. So this return data type which we write here tells the messenger, that is your function, what it needs to bring out. What is the type of value that it needs to bring back. If it doesn't need to bring anything, we use void. For example, we use void main because void function is not supposed to bring back anything. I hope this return data type is clear to everyone. Now the next word is the function name. It's basically an identifier to identify the function. And after that, we put the parameters. The if you're sending a messenger to the king of Mewar, then of course you will tell the messenger also some things, no? That okay, I need 500 kgs of spice and I need 300 kgs of silk. So the parameters, the data that you give to your messenger, to your function, those are called parameters. Okay, the information that the function takes with it for using. Then it executes things. If there is a return data type there, then it will return something. It will write a return statement. If there is not, then you don't need to. Okay, this is the basic syntax of a function. Just have a look once. It will become clear as we do an example. Okay, now just assume that somehow you own a shop where people can buy either three things or they cannot buy anything. Either they you cannot buy more less or more than three things. So every time you have to add the cost for three items. So you want to make a function to which you just tell the three items and you just adds them and it tells you back. Of course, for this you don't need a function, you can just add them. But it is just to demonstrate the purpose. So let us write a program to create a function like that. See, I'm creating a function. The name of the function is sum3. Then the parameter that the function would need, parameters will be int n1. See, these are local variables. I'll explain to you more about it, the local variables later, but just remember that whenever the function is created, these variables are created only for the use of that function. So when we are creating new variables, we need to declare them. And you need to declare them separately. You cannot write int n1, n2, n3. So these are the three parameters that the function will receive. Okay. Now, what will the function do? The function will there's a variable called sum in which the function will add the three variables and then it will return this sum. Return sum. Who will it return to? The calling function. Generally, the calling function is the main function, but it can be any other function also. If you have five functions, they can call each other. In fact, a function can call itself also. I'll show you how later. Now, this is our function that we have created. Okay, its return type is int. The name is sum3, and there are three parameters. Now, now we have to create the main function, of course. So void main. See, I'm creating fresh variables here because this function main function is completely different from our created user defined function. Now we write a general program printf, enter three numbers, then scanf, percentage d, percentage d, percentage d, and a and b and c. I hope this is not something complicated now. Now, see, result res is a variable in which we want to get the sum. So what we use this, we call the sum3 function and we pass parameters a, b, and c to them, c to the function, and then we just print res. Result equal to, and we close the main function. Guys, have a look. See what is happening. This is the calling the function. Do you see this is something similar to printf function? Printf function also we pass some parameters, but we don't get some value from the printf function because it is a void function. It doesn't return anything. But our function sum3, it is not a void function. It is an int function. So sum3, that function is called a, b, and c. The values which have been taken as input from the user, they are passed to the function. These a, b, and c go and get stored in n1. A's value comes here, n2, and and 3 में C चला जाता है, and then this function sum3, it works on n1, n2, n3, it returns the value of sum. This value of sum comes and gets stored in res, and then we print res. I hope it is clear. If anybody has a doubt here, please ask. I hope it's clear to everyone. I'll also tell you one small thing. See, these are the parameters that you send from the main function. They are called actual parameters, because they are the actual parameters that you need to work upon. And the variables which are used by the function, they are called formal parameters. They are only formally present there. And this type of transmission that we are doing here is called call by value. We'll read more about it in detail later, but I'll just tell you that in call by value, only the value of the actual parameters get copied into the formal parameters. So now in this program, if you make n1 equals to 0 somehow, n2 equals to 5, the actual parameters won't get affected. The value of a, b and c won't get affected. Okay, they are different, they refer to different memory locations. Only the value of the actual parameters is copied into the formal parameters. Okay, this is called call by value. But tell me one thing, in a void function, we have not written any return statement. So how does the control go back to the calling function? Because return statement is needed to terminate the function. What happens is, even if you have not written a return statement and the function is void, the compiler adds a return statement implicitly just to terminate the function and go back to the calling function. But that return statement doesn't carry any value. Okay. Now we'll learn about some terms which sound really cool. They're also cool and you'll hear about them a lot of times, and many a times people get confused. Method overloading. See, the name is only evident. What is overloading? If you have two, three friends, and not three, it will be too much. If you have two friends and a bike, you will have to do method overloading many times, because there you will have to sit three guys on one bike and you have to manage. So that is overloading. And similarly, if you do the same thing on a method, so a method is generally used to perform one function, but if you use it to perform multiple functions, the same method, the same name, by changing the parameters, then it is called method overloading. Let us understand it. The name of the method has to be okay. So overloading is like bike overloading. Then we use the declaring different functions with the same name but with different parameters. Let us understand this. Let us take an example. For example, I am creating some methods. Okay, just have a look. Float area a, int a, return a into a. If you guys have noticed, this is the a method to find the area of a square. If you give it the side of a square, it will give you the area of a square, right? Now see, with the same name in the same program, I'm creating another variable. Float area int a comma int b. Return a into b. See, the same method name, but now it also works if you give it two parameters, then it gives you the area of a rectangle. Okay. Now what you can do is, see what instead of making different methods, we have overloaded the same method. So now when you when you call this method, this function, it will check how many parameters you are sending. If you are sending two parameters, then it will do this, and if you are sending only one parameter, then it will do this. So here we have created an overloaded method. Okay, you can create more versions with the same name. You can create area of a triangle, you can create area of a cylinder, and all with the same method. So this this gives convenience to the user. Okay, this is a bit confusing for the programmer, but it is good for the user point of view, because he doesn't have to remember different functions. He knows that okay, there's only one function area. Whatever area I want to find, I can use this function. Okay, so method overloading is very good when for making your softwares or your programs user friendly. Okay, I'll just complete this thing so that you get an idea. For example, now I can create a main function here, and I printf enter 1 for square, 2 for rectangle. Okay, then I take scanf and I take the input in n. Now I make the n the control variable of a switch statement. Now if n is 1, this means that the user wants a square. So I'll write printf enter side of a square. Then I'll take the side of a square using a scanf statement and a anything. Then I will send this to the area function, area a, and I'll store the value in result, and then I'll print the value of result. Okay, you can't print it like this. It is just a symbolic statement for you to understand, and of course the break statement. If the user had entered 2 in the n, so case 2, then we ask him to printf enter sides of a rectangle. Then scanf %d and a and b. Then result is equal to area a comma b. Then printf result and break. And here we close the switch block. I hope it is clear to everyone. Okay. Then let's learn recursive methods. This is again a term which you will hear sometimes, and sometimes people get a lot of confusion in these methods. That's why it's a small topic, but just understand it. Whenever a method invokes itself, calls itself, it's a recursive method. It's like patients of schizophrenia, they talk to themselves, self-talk. So methods which can do self-talk are called recursive methods. Okay, they are a bit confusing to program, but what they do is they save the execution time, and they save the memory space, because you don't have to create multiple programs. I'll give you a small example, and then I'll ask you a question. For example, using a recursive method to print factorial. Okay, factorial of n. Factorial of 5 is 5 into 4 into 3 into 2 into 1. So I'm creating a recursive method here. Just have a look. Int factorial. Okay, of course this will take an input from the calling function int n. Now what it does is, if n equals to 1, double equals to 1, return 1. Okay, sorry. Else return n into factorial of n minus 1. That's the end of the function. Okay. Now guys, if handwriting, I hope the handwriting is legible. Now can you see this function is invoking itself? In this function only, this function is able to call itself. Now let us see how it will work. For example, n equals to 3. Okay, now if n equals to 1, is n equals to 1? No. So this statement is not executed. Else return n into, so n's value is 3, so 3 into factorial n minus 1. Okay, so factorial 2. Now this function is again getting executed while the parameter is 2 now. Now this, just assume that there are execution at different levels. If you have watched Inception, then it should be clearer for you. If you haven't, then just try to understand. So now is 2 equals to 1? No. So this statement is still not executed. Again we go in this statement. So return 2 into factorial of 1. 2 minus 1 is 1. Now the third time this function is getting invoked. Now what is this value of n? 1. Now if n equals to 1, yes, n equals to 1, then return 1. So now this third level, just try to understand this way, that the first time it was invoked with n equals to 3. This called the same function for the second time with n equals to 2. This called the same function for the third time with n equals to 1. When this was called, if n equals to 1, then 1 was returned. So 1 got returned from here. Then here the value was 2 into 1, which was returned here. And then the value became 3 into 2 into 1, which was finally returned to the main function, which was 3 factorial. Is this level clear to you? Is it clear how it is working? Just take 10 seconds to absorb it and understand it, and that will clear recursive method for you. Okay, just write me a program to find sum of first n natural numbers using a recursive function. Create a recursive function, find the sum of the first n natural numbers. For example, if the user gives 3, so you should print 1 plus 2 plus 3 equals to 6. And okay, now if n equals to 1, return 1. Else return n plus sum n minus 1. Close the brackets. Just analyze it and see if you are understanding it. See, for example, if n is equal to 3, so we want the first implementation will return n plus, I'll tell you. See, there are 3 levels on which the program is getting executed. Sum is equal to sub sigma. Sum is the name of my function. Sum is the name of my function. I can name this function Chatra as well. Yeah. Instead of sum, I can write Chatra here. And I can also write Chatra here. That's it. It's a name. That's all. So in the first implementation is for n equals to 3. So it basically returns 3 plus sum of 2. Now for this sum of 2, it is implemented again, the function n equals to 2. So it returns 2 plus sum of 1. When n equals to 1, this statement is true. So it basically returns 1. Now this one, it goes here. So this becomes 2 plus 1 equals to 3. And this is returned here. So it becomes 3 plus this 3 equals to 6. I hope it is clear to everyone how we have used the recursive function here. You can take one more question because the time is up. You can just try it. Write a program. This is a function question. You have to use functions. Okay. Use method. I'm writing it here because then someone will do it without method. Okay. For example, you have a shop. Okay. So you have to print for every customer, and it is Christmas, so you have to print. You have to calculate. There's a discount sale going on. So write a program to print the final amount that the customer has to pay to purchase um, n shirts at rupees X per shirt, having a discount of D% on each shirt. So basically, the customer will tell you by an input that okay, I have to buy 10 shirts, and uh, means I mean, of course, the guy on the table, the recipient desk. So that guy knows what is the current discount which is running and what is the cost of that shirt, and the customer will of course tell the how many shirts he wants. So these three inputs will be taken, they will be passed to a function. That function will finally calculate the amount, and that amount has to be printed for the customer. Okay, this is your question. You have to use it, do it by creating a method. You can give your method any name: my shop, your shop, woodland, anything. Okay, so yeah, I hope you guys have noted it down or taken a screenshot. Now we'll pack it for the day. We'll call. Thank you everyone. I'll just strongly recommend you to try the two questions, and don't delay it too much, because else you'll forget everything and it will. Okay. See you in the next class. Bye bye, guys.